See, the question, these questions are from, these questions are also doubts, but they are from the advance. What the question is, let's solve this. Let's try to solve 27 number question. Spherical wave bubble inside water has a radius of r. The pressure inside the bubble and the water pressure to be equal to B naught. Bubble now gets compressed radially in additive units so that the radius becomes r minus. A is very much r. Magnitude of work done by the process. This process is cha. This is our bubble. Now it has been compressed radially so that it becomes, it compresses by a distance of a. Initial radius was given to us was capital R. See, nothing is given to us. It's actually compressed in adiabatic manner. So if we solve using the adiabatic way, we should have the relation that also we don't have. In this case, we can use the P dV is the work done. But pressure, when it is compressed, no, pressure is also constantly changing. From this to this, let the pressure difference be delta P. But we have to take the constant pressure. Pressure is constant because this A is very much less than R, no? So that we can take the average value. So the dW becomes delta P by 2 into dV. This is P average during this compression. Otherwise, we should have something, PV power gamma, something, that relation we should have. Otherwise, we cannot do this question. So the delta W, dW is equal to dP dV by 2. So to find out this dV, P is 4 by 3 by R cube. dV is 4 by 3 pi into 3 r square dr. But almost this radius small r is almost equal to Kepler only. So we'll take it 4 pi Kepler square. dr is a, they have given. So dv has become 4 pi r square a. So this dw has become dp by 2 into 4 pi r square a. Now PV power gamma is there. P is equal to, suppose I take constant k by v power gamma, so I can write dp is equal to minus gamma v power gamma by v power 1 plus gamma dv into k minus gamma. K is again pv power gamma, I can write power gamma into v dv, v power gamma you will get cancelled, minus gamma p by v. We can write this relation actually. Here this dw work done is dp by 2, which is minus gamma p by v into 2 into dv is 4 pi r square into a into 4 pi r square into a. Right? Question is somewhat typical. So v value also we have to substitute. Minus gamma p into 4 pi r power 4 a square. 4 pi should also be square by 2 into 4 by 3 pi r 2. 4 pi I'll cancel. This r cube also will cancel. Minus 3 gamma p 4 pi r a square by 2. This is the work done that we have got. Let's compare it. 4 pi p naught r a square. 4 pi p naught r a square. So they want actually x is equal to minus 3 gamma by 2. Gamma what they have given 41 by 30. 3 by 2 into 41 by 30. Then 41 by 20. It should be approximately 2.05, I think. It should be the answer. This is the easiest way of solving this question. Otherwise, there are lengthy methods also. You can, instead of doing this, you can write PV is equal to PV power gamma is equal to constant. So you can find the work done in that case. You know, understanding? PV power gamma is equal to constant. Then you can write P as A by V power gamma. Accordingly, you write, find out the work done. Like that also you can do. Then also you solve the get the answer. Okay. Let's solve the next one. 28. Question number 28 what it says. A thermally isolated cylinder closed vessel of height 8 meter. Acha. You have to divide into equal parts. Frictionless partition of mass 8.3 kg. The mass is given. Partition is held initially at a distance of 4 meters from the top. Okay, means it is in the middle. It's held somehow. Each contains 0.1 mole. N is equal to 0.1, N is equal to 0.1. Temperature is also there. T is 300 Kelvin for both. Partition is now released. No gas is leaking. Equilibrium is reached. Distance of partition. Okay. See, it's fairly easy question, but these kinds of questions are actually regularly asked in advanced examination. Let initially the pressure be P naught, both the cases, and volume be V naught. Okay. Or you can do the whole volume is V naught, so the volume here will be V naught by 2, V naught by 2. This temperature was same throughout the process. So let this pressure, after it has moved by a distance x downwards, now let's say it has come here. The pressure of the upper part has become P1, and the pressure of the lower part has become P2. The pressure of the volume of the lower part will become V naught by 2 minus AX. The volume of the upper part will become V naught by 2 plus AX. If you talk about equilibrium with me, at equilibrium, the lower part will apply a force in the upward direction, which will be P2 into area. Similarly, the upper part should apply a force in the downward direction equal to P1 into area. But there is an mg force also acting downwards. For an equilibrium to achieve, what is the first one relation that you can write as P2A minus P1A should be equal to mg. How to get the relation between P2 and P1? For that, since temperature is not lost, you can do one thing. For each half, you can apply P1 V1 is equal to P2 V2. That is P naught for upper half, for upper section, P naught into V naught by 2 is equal to P1 into V naught by 2 plus AX. For lower section, P naught into V naught by 2 is equal to P2 into V naught by 2 minus AX. Acha, haan. Now your question is solved actually. Also we have P naught V naught by 2 for each section if you apply, because in each section number of moles was 0.1. N R T naught. N is 0.1. R you know. T naught is 300 Kelvin. In each section, so it will be 30 R. P naught V naught by 2 is equal to 30 R. Original condition I apply. I am applying originally. When it has not, it was held in the middle. So from 2, what I can get? Again, see, I can rewrite this also. V naught by 2 is equal to A into 4. Half, na? Half is area into 4 meter. So I can write value of P1 from here. From second, P1 is equal to 30R by 4A plus AX, or 30R by 4 plus X into A. From 3, similarly I can write P2 is equal to 30R by 4 minus A, sorry, 4 minus X into A. Now you have to put it in the equation number 1. P2 minus P1 into A. So 30R by A, I will take common. 1 by 4 minus X plus 1 by 4 plus x is equal to what? 8.3, na? Mass was given what? 8.3. The calculation will go higher. G value also I'll put because they have given it's 10. Yeah, this will cancel. Which I forgot to multiply here, so a this will cancel. 3 into 8.314. Oh, things are becoming easy, I think. Then. 4 plus x plus 4 minus x. Yeah, same mistake. Why I'm doing plus minus. These are cancelling. They will cancel. So 3x square. No, 3x is equal to 16 minus x square. Getting quadratic. Now here 2 also will multiply. One mistake I have. This square plus 6x minus 16. X square plus 8x minus 2x minus 16. X into x plus 8 minus 2 into x plus 8. X minus 2 into x plus 8. X cannot be negative. So x is equal to 2. This should be the answer. But they have asked from the top. From the top it will be 4 plus 2. Answer should be 6. It's solved. It was not that easy. It was not that tough, but involved the calculation. Now let us take the last question which was given to me as doubt. They're all advanced questions. Sure. What is this question? An ideal monatomic gas is confined in a horizontal cylinder while spring load. This one. Initially, the gas pressure, temperature, and volume are given as P1, V1, and P1. It was initially relaxed. The gas is then heated very slowly to the temperature T2. V1 to V2 and pressure to T2. Piston moved out by a distance x. Ignoring the piston is the correct statement. Energy stored in the spring, work done, heat supplied. Okay. Let's calculate the work done first. dW is equal to PD. Yes. At any instant, the work done is P1 plus kx by A dV. So the work done will be the integration P1 dV, which is from V1 to V2 plus kx by A dV. I can write as A dx in this case. So A will get cancelled. Here work done will become P1 into V2 minus V1 plus A x square by 2 0 to 20. This is the work done. But they have asked in terms of dV only. Say I can find out some results. Here x will be V2 minus V1 by area. Kx is the force. Which is P1 minus P2, P2 minus P1 into A. In that case, I can find out this kx square by 2. The result will be kx into x by 2. So it will become P2 minus P1 into A into V2 minus V1 by A, na? By 2. A will get cancelled. So the work done have got is P1 into V2 minus V1 plus P2 minus P1 to V2 minus V1 whole divided by 2. Now let's find out the results. V2 is this is this energy stored in spring. Pressure we have to find P1 V1 by T1 is equal to V2 is what? We don't know. V2 is 2V1. P2 is 3T1. This will cancel. So P2 will be equal to 3P1 by 2. So we have found the energy stored in the spring is E is equal to kx square by 2, which will be equal to P2 minus P1 into V2 minus V1 by 2 will be 3 P1 by 2 minus P1 into 2 V1 minus V1 whole divided by 2 will be P1 V1 by 4. This is the energy stored. So that means option number A is correct. Let's go for the option B. Change in internal energy. Internal energy is what? NCV delta T. This is what? Monatomic gas, na? 3R by 2. And into 3R by 2 to T2 minus T1. So T by 2 nRT2 minus nRT1 3 by 2 into T2 V2 minus T1 T1 3 by 2 into the same condition, exactly same. They are asking in terms of P1. 3p1 by 2. V2 is what? 2v1. 3 by 2 into 2p1 v1. 3p1 v1 I'm getting. Correct. It means option B is also correct. Now let's check for the option C. V2 is this, the work done by the gases. V2 is 3v. T2 is 4t. So P1 V1 by T1 is equal to P2. So we will have 4 by P1. Yes, to work done by the gas. W. P1 into 3v1. P2 minus P1. You have to use this relation. 2v1. 3v1 minus P1 plus P2 minus P1 is 4 by 3 P1 minus P1, which is P1 by 3 into 2v1 whole divided by 2 plus 1 by 3 P1 V1. 7 by 3 P1 V1 is the whole work done. This is correct. The option is also correct. Coming to option number D, same case, heat supply to the gas. Heat supply to the gas is dq is equal to du plus dw. Du is what? Into 3r by 2 into T2 minus T1. That's 7 by 3 P1 V1. 3 by 2 into nRT2 minus nRT1 plus 7 by 3 P1 V1. 3 by 2 into P2 V2 minus P1 V1 plus 7 by 3 P1 V1. P2 is what? P2 is 4 by 3 P1. V2 is 3 V1. It's almost solved. 3 will get cancelled. 3 by 2, 3 P1 V1, 4 P1 V1 minus P1 3. 9 P1 V1 by 2 7 by 3 P1 V1. So it will become 41 by 6 P1 V1. So option number D is wrong. V2 is 4 by 3 V1. Let me check again. V1 into V2 is 3 V1. 7 by 3 V1 V1. V3 get cancelled. 4 minus 1 is 3. 9 by 2 by 3. 14. 41 by 6. Okay. So this option is wrong. So the correct options are A, B, and C. Is solved.